This is part two of a video series that illustrates the use of data modeling anti-patterns. I'm Michael Blaha. This video right here applies anti-patterns to a case study of the LDAP standard. So part one, which is a separate video, which hopefully you've already seen, explained the term anti-pattern and presented several data modeling examples. So let's talk about reverse engineering the LDAP standard. Let me first define the term reverse engineering. Reverse engineering means that you start with a database schema and you go backwards to the model of the intent. And why do you do reverse engineering? There's all kinds of reasons. One reason is if you're redeveloping an application, you want to start with what's there, extract the model, improve it, and build forward. Another reason is if you're buying a product, you can reverse engineer the database to gain insights into the product. And that's the case in terms of this LDAP standard. So LDAP as a standard arose from files. It was built on files. But in this particular case, I was studying a LDAP product that was built on top of a relational database. And there's going to be some criticisms here, and just so you don't have the wrong ideas, criticism is not of the product. The product is faithful to the standard. The criticisms are of the standard, and there's some bad things about LDAP because it was built on a hierarchy of files. It wasn't built on as rich a substructure as relational databases, and actually, by its nature, an LDAP product underutilized relational database. So what I had for inputs for the reverse engineering was schema. I had tables, attributes, data types, nullability, and primary keys. I had data, and I had a book explaining LDAP concepts, so I understood what LDAP was. So there's a total of 11 tables I had with which to work, and here's an example of one. You can see iReplication keys, the primary key. You can see the data type and all these other things, are fields that happen to be not null. So I was given 11 fields. And one of the interesting things about LDAP is there's 11 tables. 11 tables, some store metadata, some store data. So LDAP's tables store the model, that other LDAP tables store data that adhere to the model. Now here's one observation. So I just showed you one of the 11 tables. You can't see all the 11 tables here, but I'll tell you that they have a very strong and uniform style. That's a good thing. That's a sign of professionalism. That actually is a compliment to the vendor here that built LDAP on the database. At least their style is relatively uniform, and all the primary key fields are in 4. So here's one of the anti-patterns that's manifest. One of the tables here in the vendor's implementation is called object attributes. And you can see there's 5 parallel fields: VC value, I value, VB value, image value, and date value. And the reason for that is object attribute stores the value of an attribute for an object. It's intended to be weakly typed, and one of those 5 is populated, the other 4 left blank. So that's strictly speaking, that's parallel attributes, but that's a reasonable use. It seems okay here, but nevertheless we acknowledge it. Here's another anti-pattern. This one's not so good. So I value, it stores integers. Well, it actually also stores pointers to objects, which happen to be of int4, so they're the same data type as integers. How do I know that? Well, I inspected the data. When you inspect the data, it's obvious. So it's really quite awful. Here's a field that's storing both integers and pointers. There's no prayer whatsoever of trying to make sure that there's no dangling pointers and making sure that there's bona fide references, and that's really ugly. And that ugliness is mostly a consequence of LDAP's heritage of being designed for files. LDAP does not avail itself of referential integrity in relational databases, which is a shame. Here's another anti-pattern, a modeling error. So here's 2 tables in the LDAP implementation, 2 of the 11. One is called class containers, one is called classes. If you look at class containers, it has a primary key. It has 2 additional fields which are foreign keys, both of which refer to classes. So what class containers says is that the same class and the same container class can be entered multiple times, and of course each time is entered as different replication keys, different primary keys. But think about it. So you have a container class, it's called A, that can contain class B, it can contain class B again, contain class B again, how do we tell them apart? There's no notion of roles. It's not good. So for example, we could have maybe a department would be the container, the class A, and the inside class could be a person who's a manager, could be a person who's a secretary, could be a person who's in some sort of a audit capacity, who knows what else. So there's an example of where you'd like to say, it's not good enough to say it's a person, but we have to say what's the role of the person. They're a manager, they're a secretary, they're in audit capacity. So there's two possibilities with class containers. One is that it's just flat wrong by not having the roles. And the other possibility is that programming code only allows one combination of container and class, and that's not obvious from the schema. The software might happen to work okay in that case, but it's really sloppy. Constraints should be in the schema. They shouldn't be in programming code. Another observation in terms of an anti-pattern, there's severe paradigm degradation. LDAP forces data into a hierarchical structure. There's a parent which contains children, which contain grandchildren, and so forth, walking down the tree. And that's the way LDAP works. And in that sense, it's very much like a hierarchical database, but it's not built on the idea of a relational database where you got key tables that happen to refer to each other in terms of like a network. So a consequence is LDAP foregoes referential integrity and uses pointers, and programming code must handle the pointers. And one very telling aspect of the LDAP book that I read, they had an entire chapter on exception handling. What happens if you have a pointer that's bogus? If you have referential integrity, you don't have to worry about that. The referential integrity guarantees that your references are real. So hopefully you found both these videos helpful. If you find them interesting, there's more about anti-patterns in my recent book, as well as other sorts of data modeling patterns. So you got the reference there. If you're interested in me for training consulting, got a reference here to my website. Setting aside my books and my business, if you have any questions or comments about these videos, please feel free to send me an email. I'll try to respond. Thank you for listening.